Good morning, everyone. Thanks for coming to my talk. So this presentation, Presto On Spark, a unified SQL experience, is a joint collaboration between Ariel Weisberg of Meta and me. So Ariel could not join us today, and I'm going to cover his part as well. So this presentation is going to be divided into two parts. The first half of the presentation is going to cover the motivation behind building Presto On Spark, the library itself, and then we'll talk about the implementation at Intuit. So why Presto On Spark? So let's do a quick poll. How many of you have run into the situation where you are thinking or you're not sure where to use, say, Presto or Spark SQL for your query? Have you guys run into the situations? I see a few hands. So Presto and Spark SQL, as you all know, are the most popular dialect used in the industry for query processing. But each of the dialects has its trade-off. Customers doesn't necessarily understand when to use which dialect. They don't necessarily understand, what are the memory or the compute needs of the query. They would not necessarily know what is the internal architecture of these engines and what are the optimizations that goes with these queries. So this is a quote from a Presto user. Users tend to like Presto in general, especially if they are coming from writing queries in an analytical database, say Vertica. It's easier to write, fast, test. Whereas with Spark, if you are using open source Spark does not have an exploration environment. So testing your queries, debugging it, and authoring it adds a little overhead and takes time. Whereas with Presto, it's fast to test, and it's easy. But with Presto, you may often run into out-of-memory errors. And as a workaround, I have seen users splitting their queries, trying to make it work, break their queries. They apply Presto session properties, or they will do many optimizations. And when these optimizations do not work, that's when they switch to Spark. So this image depicts users or customers' emotions. This is exactly the sentiments that we see at Intuit as well. So users does not necessarily know, when should I use Presto? Should I use Spark for this query? I see an out-of-memory error again. Oh, no, I have to work around the limits. And these are the questions also that we get in our support channel. So the next couple of slides are going to cover about the strength and the weaknesses of each of its dialects. So as you all know, Presto is ANSI SQL. It's widely adopted. It was built at Facebook. Facebook extensively uses Presto. Uber uses Presto. And it is also used at Intuit for interactive analysis. It's fast. Most popular interactive analysis tool. It provides federated query design. So federated query design means that you can connect to heterogeneous data sources, such as MySQL, Cassandra, and Hive. You do not need to preload the data in memory. You can just get the data from various sources in the same query. And as you all know, that users use Presto for interactive workloads, they naturally tend to use the same query for the batch workloads. And over a period of time, your data sets tend to naturally grow. And that's where the weakness of Presto comes with respect to the scale limitations. So because data sets are growing naturally over a period of time, you can easily run into out-of-memory errors because Presto tries to do everything in memory. And long-running queries are at risk of failures because Presto is not fault-tolerant. Now, let's look at Spark strengths. So Spark is the tool of choice for batch queries. Spark has been designed keeping scalability in mind. It can practically offer unlimited scale. it can scale up to many big clusters. On the other hand, with respect to weakness, if you are using open source Spark, it does not have an exploration environment. Databricks has come up with SQL, which offers an exploration environment, but if you use open source Spark, you have this latency overhead. So the next few slides are going to talk about, I'm going to talk about the motivation behind building Presto on Spark library. So we will talk about the Presto architecture, and I'll try to explain why it does not work for batch workloads. So let's revisit Presto architecture. As you all know, Presto is designed for interactivity. It is low latency. There is no startup or delay time. It follows a classic MPP architecture. The JVM is always warm and ready to execute queries. You have long-lived JVMs running. It offers multi-tenant service. So multi-tenant service means that you can have multiple queries which share the same JVM. And it uses in-memory streaming shuffle. So what does in-memory streaming shuffle mean? So that means that your mappers, they write their shuffle data to an in-memory buffer, and then they wait for reducers to consume that data. So that means that in Presto, your intermediate shuffle data is not persisted to disk, but it is continuously streamed from your mapper to reducers. So this makes Presto shuffle very fast. Another key point to note with respect to Presto architecture is it does not enumerate all the splits on the Presto driver or coordinator. It enumerates a small number of splits and assigns it to tasks lazily so that Presto query execution can start immediately without waiting for the driver to enumerate all the splits. So all of these features of Presto makes it very fast and low latency. But then you come into the scalability limitations. So I'll try to explain those with a query. So this query goes over TPCH, orders table, and is doing a group by on the customer key. So as I mentioned that Presto does in-memory streaming shuffle. That means it has to move all the data continuously from the mappers to the reducers. And if it is not moving the data continuously, what could happen? So because all the data is stored in in-memory buffer, your in-memory buffer on the mapper side can get full and stall the execution. And on the reducer side, your in-memory buffer will be underutilized and cause unnecessary operational overhead. So that means that everything in Presto is executing concurrently. And so say in this case, you're doing an aggregation on total price. So it has to load all the data for that customer key into memory. So it causes inflexible scheduling. Presto does not offer fault tolerant. If there is any task failure in the later stage, your query fails. And you can easily exceed memory limit. Also, as I mentioned, that it is sharing, all the queries are sharing the same JVM. You could have one bad query negatively impact other queries or negatively impacting the cluster. So let's look at Presto Unlimited. So Presto Unlimited was again developed at Facebook to solve the shuffle problem. So Presto Unlimited brings this map-reduce style shuffle on Presto side. So now instead of your shuffle data being streamed from your mapper to the reducers, it is persisted, the intermediate data is persisted on disk. So now since your intermediate data is persisted on disk, say for this query when you are doing an aggregation on customer key, it does not have to load all the data into memory, but it can load data for few partitions into memory, and it can thus reduce the peak memory usage. And also because your intermediate data is persisted, if there are task failures somewhere later in the stage, since your data is persisted, you can always retry. So this brings more reliability in execution of queries, and you can scale large memory queries, and Presto Unlimited can run on existing Presto deployments. But then there are limitations. It still does not offer any resource execution, so you can still run into this issue that you can have a bad query, which can negatively impact your other queries in the cluster, or it can negatively impact cluster. It's still, the fault tolerant is not foolproof, and it is hard to add or reduce workers for a given query or on the cluster. So that's when Presto on Spark comes. So I'm going to touch base upon Spark architecture before talking about Presto on Spark. So let's revisit Spark architecture. As I've mentioned, like Spark has been designed keeping scalability in mind. It can practically offer unlimited scale. You can reliably execute your query on petabytes of data. It can scale up to thousands of executors. You get isolated executors for each query, so you don't have one queries intervening with other queries or negatively impacting the cluster. You can always retry a stage or a task. You get flexible resource allocation. So if you are using Spark's dynamic allocation, you can dynamically allocate resources for a query. You can scale up and down your cluster. If you are using Databricks auto-scaling, it is more intelligent, and you can do the auto-scaling it on other metrics, on some metrics such as your active task or pending task, and it has more intelligent algorithm. And if you are running your workloads on cloud, you leverage the elasticity of cloud, and you can also optimize on cost and performance. So if Spark offers all these capabilities, why not simply use Spark? Or why should I not translate my query to Spark, right? The query translation thing obviously comes into mind. Writing a query translation library is not easy. It is tedious. And even if you have a very solid query translation library, LinkedIn has developed Coral, which is an open source library built on top of Apache Calcite, which offers conversion from Hive to Presto, but not from Presto to Hive. But still, you can always build a solid query translation library. But there are the subtle differences that you need to take care of. So for example, Presto int cast of 1.8 returns 2, whereas Spark returns 1. And both Spark and Presto SQL are ANSI SQL, but the ANSI SQL spec says that it is left up to the vendor when to return null or when to throw an exception. So building a unified SQL experience, its engine is not just about the same dialect, but the experience should also be the same. And then you also have the user-defined functions, or UDFs. You have to then manually port your user-defined functions from one engine to the another. So there are additional features of Presto which makes it powerful, right? Which you want to use, like the query federation capabilities, which allows you to connect to multiple heterogeneous data sources. Presto offers a powerful geospatial toolkit. The Presto geospatial function supports a well-known text and well-known binary format of spatial objects. You have a project area, which offers smarter table scans. So say if you are reading map structure into memory, you don't need to, it provides subfield pruning, so you don't need to read all the keys, but you can just read the specified keys. It also provides efficient row skipping and adaptive filter ordering, so you can immediately get performance gains. So all these features of Presto makes it very powerful. So now comes the Presto on Spark. So Presto on Spark is a full Presto library that is running on Spark. It's not a query translation. You get 100% SQL compatibility out of the box. It's transparent to users. As I mentioned, it's running as a library. You don't need a Presto cluster. It's running as a Spark application, queries passed as a parameter, and it's implemented on RDTs. So Presto on Spark, it produces two artifacts. One is the launcher, and the other one is the Presto Spark package, which contains all the dependencies. One important thing to note is the Spark task CPUs. That this configuration means that you are allocating all your cores to us. It indicates how many cores you are allocating to a task. So keep track of this, and it's an important config, and we'll revisit it later. And then these are all the config catalogs, or these are all the Presto properties. Config points to your Presto session files, and catalog contains your Hive connector properties. So let's look at Presto architecture, Presto on Spark architecture. So you have this Presto SQL, which is an input to a Spark submit. And within the Spark driver, it is the Presto query planner and the optimizer, which is being executed. So within a Spark driver, we will enumerate all the splits, get the Presto logical plan, convert it into a Presto distributed plan, and then finally convert it into a Spark RTD to be distributed across the cluster. So Presto also serializes the plan, and that plan is sent to the Spark executors. And it communicates to the Metastore via thrift server. So within Spark worker, it's again the Presto evaluation library which is being executed. So say if you have, say if it's a scan task, your input is going to be splits, and your output is going to be the shuffle rows, or the serialized rows. So as I had before mentioned, that you are actually sending the Presto logical plan to the Spark workers. You basically deserialize the plan and then convert it into Presto executable operators. So for a scan stage, as I mentioned, it is splits, and your output is the shuffle rows. And say if it is final stage, as the writer stage, your input is going to be the shuffle rows from the upstream stage, and your output is going to be, say, write to table. But before doing that, you can do a join or an aggregation, and it will be the Presto code base of the Presto evaluation library, which will be executed. So as you observe, that it does not use any of the Spark capabilities. It does not use Spark Planner or Spark Optimizer. It uses, it operates at RDD level. It does not use any of the Spark APIs to communicate with S3 or Hadoop or any of the other data sources, but it's all the Presto evaluation library which is executed on the driver and within the Spark task. But it is leveraging Spark for the shuffle capabilities. So if you are using open source Spark, or if you are using Databricks, external shuffle service is enabled by default. But so Facebook uses Costco as the shuffle service, but you can always plug in your own shuffle service. It also leverages Spark for query execution. So now you see that all the queries are executing on isolated executors. So you will no longer have this problem of one bad query intervening with other queries. And it also leverages Spark's cluster manager or Spark's elastic compute for better resource management. So now, if you're running your roles using Presto on Spark, you can practically throw more compute for queries that are complex, and those queries will perform well. And you can reduce the compute for small queries. And thus, if you're running on cloud, you can optimize on performance. So let's look at the Presto query plan. So the Presto query plan, as I mentioned, it runs on the driver. This is a simple query which is doing join on to table. And what you see on the left is the logical plan. What you see on the right is the Presto distributed plan. And the fragment here represents the Presto stage execution. And here you are doing a redistribution on the order key. So let's look at the Spark DAG. So this is what you're going to see on the Spark UI. The stage 0 and 1, it corresponds to the scan inputs. The stage 2 is the shuffle. You're doing the shuffle and join here. So important thing to note is Presto uses custom RDDs. So it uses Presto Spark Task RDD, which extends which extends zip RDD. Zip RDD means you can arbitrarily join n number of RDDs. And Presto Task RDD represents a stage of execution in Presto on Spark, and it contains this Presto Task Source RDD, which I mentioned corresponds to your scan inputs, and Shuffle RDD. And within each of the RDD's compute methods, it's again the Presto evaluation library or Presto code base which is being executed. So this slide has the link to the Presto on Spark design docs. If you are interested in details, you can look into that. So threading model. So as I had mentioned that Spark task CPU config in the previous slide, so that's very important. So in Spark, by default, you allocate one core for every task, but Presto allocates all the cores for running one task. So you'll always see one task on an executor, but within each task, Presto does another local in-memory shuffle, and for each of its subpartition, it assigns a thread, and that thread runs in parallel, and that thread pool is internally managed by Presto on Spark. There are a couple of advantages that you get out of this. So the first advantage is because you have one task output per executor, you reduce the overall load on the shuffle service. And it also kind of solves problem with, it kind of solves the small I/O problem, the I/O problem with small shuffle files, because now for each executor, you will have one big shuffle file as an output rather than small files. And it also solves the overhead with memory overhead with broadcast joins. Because you have one task running on each executor, that means you will have one copy of data on each node. So it saves you on memory. So to summarize, what we have learned is that with Presto on Spark, you can, using Spark, you can basically work all the queries which were failing on Presto on Classic today can scale using Presto on Spark. And I would like to say it as, it's Presto working on Spark, but it is transparent to customers, and you get a unified SQL experience. So on the exploration side, you use Presto SQL dialog, you get the low latency from the Presto evaluation engine, and on the batch side, you scale it using Spark. So what's coming next? When you're using Presto on Spark, you will have to manually tune the parameters like the SQL shuffle partitions, which is called as query hash partition count in Presto, and the Spark dynamic allocation max executor. So with the features coming in, you don't need to do that. It offers Velox integration. Velox is the Presto team is rewriting their core engine in C++, so you'll get better performance when you move to Velox. The Spark's adaptive execution capabilities are also being implemented in Presto. You can coalesce small files and upgrade to Spark 3. And so Presto on Spark currently uses Spark 2, but there's a plan to migrate to Spark 3. So one important thing to also note is it's also revisiting the cost-based optimization framework so that it produces more correct results. So now let's look at Presto on Spark implementation at Intuit. So Intuit's mission is powering prosperity around the world. And to do so, we are transforming into an AI-driven expert platform. So this is Intuit's data landscape. We have around 200K tables. We produce petabytes of data. We have produced this data over a period of 30 years, and we serve 100 million customers. And now Superglue. So Superglue is a homegrown tool built at Intuit that helps user build, manage, and monitor data pipelines. I have been part of the Superglue team since the beginning. Superglue was built to democratize data for analysts and data scientists. Superglue minimizes time spent in developing and debugging data pipelines and maximizes the time spent on building insights and AI/ML. So this as Superglue users, we practically serve almost 90% or more than 90% of the analyst community at Intuit. So the problem statement which was given to us was, there are many group of analysts who are doing exploration on Athena, which uses Presto SQL, and then they come to Superglue to schedule their Presto SQLs. And Superglue was primarily using Spark SQL as the dialect. And as you all know, the dialect changes are not fun. It requires multiple cycles, and then the analyst has to manually convert their code from Presto to Spark. Now, this slide shows the journey map for an analyst. As you see that there are various phases. There is an exploration and analyze phase, there is a process phase, and then there's a visualize phase. So Presto SQL and Spark SQL are the two major dialects which is used within Intuit. So for exploration purpose, so if you are using Spark SQL, you basically, because it's the same dialect, you don't have to do conversion. But if you are using Presto SQL, you go through this series of conversion. And as I mentioned that, it's not just a SQL conversion, which is tedious, but there are also the subtle changes, subtle differences in these dialects that you have to take care of. Now, usually, when you are developers, if you are using a certain dialect, you usually tend to develop best practices for that engine or dialect, which may not typically apply for the other dialect. And then the query performance, those aspects are different for these engines, and there is definitely a lot of learning curve involved, which leads to productivity loss. So the ask to us was that you provide a performant platform and the analyst asked us to provide them with a simple unified experience to explore, process, and visualize data. So we looked at various options. The first obvious option was query translation library. So we looked at Codal, but it offered query translation from Hive to Presto, but not vice versa. And as you all know, that the challenges with query translations, we did not go for that. Then the other option is to try out query virtualization, but as you all know, it's not easy to build query virtualization platform. So we have built something known as low-code, no-code framework at Intuit, which is called as Simplan. There was a talk on Tuesday on it. So it offers an abstraction over runtimes, extraction over the engines, but it's and at some point in time we are planning to open source. And then the third one is option was we explore on Athena and you process using Presto, but you all have seen the scalability limitations that we can run with. And then the last one was Presto On Spark, which was a win for us. So this is a high-level implementation at Intuit. I'm not going to go into detail, but at a high level, user comes and schedules their jobs on Superglue. They build their pipeline, and that's being scheduled. It goes by infrastructure abstraction service. This service offers an abstraction over various runtimes that we have, Databricks EMR, and we are running on Databricks 9.1 version, and we are running on E2 workspace. And there was again a talk yesterday on scaling into jobs using Databricks. So, and the entire Superglue team is here, so if you have any questions about that, you can ask us later. So the next 4 or 5 slides, we are going to talk about the challenges that we ran into. So we took an open source Presto On Spark library, and we converted into a product which is used within Intuit at scale. And if you are using Presto On Spark, you may relate with these challenges, or if you plan to use Presto On Spark in future, these may come handy. So the first thing was the Presto On Spark library and Databricks runtime has version conflicts, but the Presto team has managed it very well. It has provided class loader isolation, but we still ran into conflicts in Java and IO library. We have applied a patch, and we plan to contribute it back. Then the other challenge was Presto open source library. You can run only one query at a time, and for us, it required us to run the entire script. So as I had said, that Presto Pro produces two artifacts. It produces a launcher jar and produces a Presto Spark dependency package. So we actually we replace the Presto's launcher code with our custom launcher code, which is based on top of Simplan, and we have the fix there. We'll either contribute back to open source, or if we decide to open source Simplan later. And then the other challenge that we ran into is cluster autoscaling. So this was very important for us because the analyst does not need to take care of defining the number of nodes or the autoscaling. We take care of it. It's opaque to the users. So if you are using Databricks, don't use Spark Submit because your jobs are not going to scale, but use a jar task. It requires access to shared Spark session. And again, this is used in the custom Presto Spark launcher code. Now, Presto On Spark library does not have a DDL support. So we were executing Hive-style DDLs because Athena also does that, but we have contributed back the DDL support. Then the other was the tables just created were not discoverable outside Superglue. We applied a patch to provide public read grants, and as part of the DDL support, you can always run grant statements. Then we provided a fix for processing legacy tables, which is created by Hive. Now these two are interesting ones. So Presto On Spark engine was not able to identify the broadcast join correctly. So we were seeing that even if the join is eligible for broadcast join, it was always defaulting to hash join. So we applied a workaround fix, and the workaround fix was, so whenever any of these engines, right, Spark, Presto, any of the big data engine, when you have to run compute cost, it looks at certain heuristics, which is, say, CPU size, or I/O, or memory cost. And then memory cost was always coming to be 0 for some reason for Presto jobs. So the workaround fix was to ignore the memory cost and take the size into account, and size is a good enough factor to decide whether you want to do a broadcast or a hash join. But a permanent fix has been applied, which takes the custom, the source size into account if their cost-based optimizer fails. And then the other one, interesting one, was netty out of memory error. So we are using Spark's external shuffle service, and you can see a memory, and we are seeing memory leak with that. So the recommendation from Databricks was to use Spark 3. So that's the permanent fix, but as a workaround, we increase Presto query hash partition count that corresponds to SQL shuffle partitions if you're coming from Spark background. You can always throttle the fetch request within a task using Spark config properties, and then you can always move to a more optimized cluster or your instance type. So these are the last two set of challenges that we saw. So the first one is if you are using Databricks and if you are leveraging Databricks autoscaling, by default it does aggressive autoscaling. That means that even if your executor nodes or your node has shuffle files, it was still killing down the nodes, and we were seeing all kinds of errors. So you can apply this property, and it controls the downscaling, and after that, we have been seeing everything has been running good. Then the last one here is you have, if one of the asks from analysts was that we want to read from Hive views, and Presto On Spark library does not currently provide support for reading from Hive views. So we looked at LinkedIn Squirrel, that query translation library, and provides that support. And we have tested this, and we also plan to contribute it back. So the last, so the success metrics. So we released a Presto On Spark solution last year, and we have now over 2,000 jobs running successfully in production. We have improved analyst productivity, and we also, Presto On Spark solution was used to power the tax season for this year. And that's the user feedback. And that's the last slide. So key takeaways, why Presto On Spark matters. The first one is There is no query translation required. You can scale to large data volumes, leveraging Spark Shuffle capabilities. You can reliably run long-running jobs. You get the fault tolerant out of Spark. You don't have queries intervening with each other. And you get elastic compute from Spark. And the last one is you get a unified SQL experience between interactive and batch use cases. Thank you. That's my social media handle. If you have any questions, you can reach out on Presto Slack channel. All the Presto developers are here, and you can tag me or Ariel. Thank you. I think we are right on time.